All right, 6.5, discounts and markups. So this section's fairly straightforward once you get the hang of it. So we're looking at discounts and markups, and I have the formula here. A discount, another, be like the sale price or a reduction in price, or it might say there's a 20% discount. So we're trying to figure out, okay, what is the sale price? Like, you're the buyer. How much am I going to pay if the original price is some amount? And then I'm going to subtract the discount. Okay, so the discount is the original amount times the percent as a decimal, right? So if it's $80 and 20% discount, it'll be 80 times 0.2, right? The original amount was 80 times 0.2, and that'll give us the amount that we are going to subtract from the $80. So 80 times 0.2 is 16, right? So, let's see, 80 times 0.2 would be 16. Sorry, I was confusing myself for a sec. That happens. So we're going to subtract 80 minus the 16 to get the sale price, and the sale price would be $64, right? Okay, markup is kind of like tax. There's a 5% tax on whatever you're buying. You need to leave a 20% tip. If you're a store owner, the cost that you pay, that's kind of what they're thinking here more with markup. But markup is also tax, tip, increase, any kind of increase, and it's all done the same. But anyway, the cost that the store pays, so imagine you're the store owner here, and you pay, $10, and then you mark up 50%, right? So 50% would be $5, so that'd be 10 times 0.5, which is $5. So again, it's the original times the percent to find the markup. Only the difference is you subtract. Let's highlight this so we don't forget. We subtract here and we add here because this is a markup and a discount. Okay, so hopefully that makes sense. In one, you're reducing it, so you're subtracting, and in the other, you're increasing it, so you're adding. Like, you just have to sometimes think about what the problem's asking. Now, there's this one down here that I want you to search for, which is original price. If it asks for the original price, it's given me and this is the one that you can use to be like, Mom, look at these cleats. Like, they were, so all we know is that they're now $33, right? But you can't tell her how much they were. You just know they're 40% off. Okay, so we're going to figure out how to tell her, like, Mom, if we didn't get this 40% off, these would have been blank amount. We're going to do that in a second. Okay, but let's just do a problem really quickly. Trying to make my videos shorter if you haven't noticed. Okay, the original price of a video game is $35. What is the sale price? Okay, so we're going to take our original amount. Here, let's, why not do it in this color? Our original amount, and we're going to subtract the original amount times the percent as a decimal, okay? So let's do that. So the original amount's 35, and we're going to subtract 35 times, and we have right here our 25% off. 0.25 is 25%. If you're confused about that still at this point in the chapter, I suggest you go back and take a look at the first section video so you can remind yourself how that works. And that's $8.25. So now I have 35 minus $8.75 and plug that into my calculator, and I get $26.25. So the $26.25 is the sale price. So it was $35, and now you're getting $9 or $8.75 off, right? And that's how that's done. If this was a markup, the only difference, I would do the exact same thing, only I would add $8.75. So if it said the store paid $35 for the video game and adds 25% for markup, then you would just add the $8.75, and instead of it going down from $35, it would go up from $35. Okay, so now when we have an original price, this is why the percent equation comes into play, and why I made sure to teach this. So if we remember, A being the part is equal to the whole times the percent as a decimal, right? Percent as a decimal. All right, so here's the thing. We don't want to know what 40% of 33 is, okay? We want to know 33 is 60% of what? And so what you do is you take 100% and you subtract the sale price. Now, again, this is when you're looking for original price, okay? So keep your eye out for original price problems, okay? So we know is my part. So we have $33 here. So but anyway, we ended up with 60% or 0.60. So 33 is equal to our whole, which we don't know. That's what we're solving for. 60% as a decimal is 0.60 or just 0.6. So because I want to make sure I do this right, I'm gonna do 0.6W, which means simply, it's still this up here, this W times the percent. I just flipped them around and made it look like what we're used to seeing. So then I just divide both sides by 0.6 to solve for W, and those become 1, and therefore our whole, or the original price, is 33 divided by 0.6, which is 55. Give it a quick, does this make sense? Yes, like 55 is more by quite a bit. So Mom, we've got to buy these cleats now. They normally are $55. You're saving a ton. Anyway, all right. Sorry, parents, if you're listening. But anyway, hope you're having a good day, and we'll see you next time. Bye.